My name is Dan Lorenc. I'm a member of Google's internal security team, but my specific focus is actually on open source security and how that affects our internal platforms. So it's awesome to see Michael's on the agenda now. Michael and I work pretty closely on a bunch of areas in open source security. I think I'm going to cover a little bit there just to kind of tee up for Michael, explaining why open source security is in such a bad state today, why huge companies like Google and Microsoft are concerned about it. And then I'm going to talk about some of the best practices that we do for our cloud platform and that we recommend for our customers on how to help secure yourself and improve your supply chain. Supply chain security is probably top of mind for most people here. It's been in the news a ton this year, starting with the SolarWinds breach. There's almost a new one every single week. So hopefully this is a timely topic. Here we go. I will jump in. So I've been at Google for about 9 years. I've been in cloud for almost the entire time, up until about maybe a year and a half ago when I switched over to our internal security team, working on the same kind of supply chain and open source security things that our cloud platform cares about. I've worked at pretty much every level of the stack here at Google, from our high scale systems and front ends all the way down to developer tooling and developer UX. In the security space for the last 3 years, like I said, particularly open source and supply chain security, but I'm no longer actually in the cloud business area. So I'll start out just by hopefully scaring people a little bit on the current state of supply chain security, and then particularly in the open source area. Then I'm going to go to the kind of crux of this, which is our big best practice around supply chain security and security in general. But the key word here is kind of the word resiliency. If I scare you enough in the first part, you'll realize that it's too late to really lock everything down and secure and make everything perfect and prevent any supply chain attacks. But what we can do is figure out how to make ourselves resilient to them so that if they do happen, we can mitigate the effects of them, we can recover from them, and that they're not the end of the world when they do happen. And the reason this is so important is because our supply chains as an industry are so intertwined, right? Nobody is building software in a vacuum. Nobody's building software completely by themselves without taking components and packages and binaries and systems from other companies. So that's kind of the problem with supply chain security. You're dependent on every single one of your vendors and every single open source contributor that works on projects that you're using. And then anybody that you sell software to is dependent on you. So we're kind of connected in this big web, which is why you see a whole bunch of big companies working together to try to solve this problem collectively. And that's why resilience is so important here. All right, we'll get started. I'm going to start out with, the problem here with supply chain and open source security. I like to describe this as two problems, particularly when we talk about open source and how that fits into our supply chains. The two problems are that it's open source and that it's software. Pretty easy when you think of open source software. I'll explain what I mean here in the next couple slides. But what I mean by open source is that it's open. Anybody can see it, anybody can contribute to it, which is awesome. That's why open source software is so heavily used, both within cloud platforms and throughout the rest of software. But the problem there is that anybody on the internet can contribute to it, and not everybody on the internet is nice. And so there's a lot of challenges to watch out for here. The second problem, which is completely different but still results in the same kind of issues, is that it's software, just like any other software. All the software we use today has bugs in it. All the software we use today has vulnerabilities in it, some of which we know about, some of which we don't yet. It's all got to get fixed. So just because you grabbed a popular package with millions of stars on GitHub and used it doesn't mean it's secure, it doesn't mean it's correct, it doesn't mean all the bugs are caught. So that's a common misconception that results in a lot of security and particularly supply chain issues. Let's go through some more details. This is the example I always like to use when talking about open source security and security in general. Hopefully most people here in this webinar and most people in the industry know that if you find one of these USB thumb drives sitting on the ground, actually, a lot of people here probably don't even recognize these, but these are how people used to transfer files between computers before Dropbox and Drive and things like that. But if you find one of these on the sidewalk, say outside of your office, you shouldn't pick this thing up, bring it inside, and plug it into your workstation. Right? I hope your security teams have warned you about attacks like this. It sounds a little silly, but attacks have actually happened. Nation-state attacks have happened like this by planting thumb drives with malware on them outside of offices and waiting for people to take them inside and plug them in. So hopefully most people have been scared by their internal security teams to not do something like this. But the interesting part is that if you take an open source package from the internet, say just npm install foo, you're essentially doing something much worse because you're taking some code you've never seen before from people you don't know or trust, and sending that right to production in a lot of cases, which can be worse than plugging it right into like a development laptop. So there's not really a huge difference here between the two situations, but one should hopefully trigger a whole bunch of fear and revulsion, and the other one is something we do probably a couple dozen times a day in modern software development. That's kind of the state of our supply chains. It's scary, we don't know what's in it, and there's malware everywhere. A couple more details here on some of the problems and opportunities that we have to fix things. Particularly on that first part, how open source fits into our supply chains. The first one here, one of the huge reasons people use open source software is that it's free. I'm going to explain all of these after some actual attacks that have happened to kind of build up on the scary nature. So open source is free, that's great, but sometimes free isn't worth it, right? Sometimes the problems you're going to get for using free software, particularly security problems, are worse than the benefits you're going to get. Got some scary examples there. Anyone can contribute. That's another huge reason people like open source. You can fix your own bugs. Now, the problem here, not everyone is nice, like I mentioned before. There are bad people on the internet trying to put malware into open source projects to make it into your company. It's also very easy to use. It's really easy to grab open source. It's much easier than going through procurement. It's much easier than getting a lot of closed source packages set up. But in some cases, that makes it too easy to use, and your development teams can be grabbing packages you didn't know about and getting them running without really any policy or checks. The final one here is kind of a misconception, right? People tend to think open source is transparent, therefore we'll be able to see any malware inside of it in the code. Which sort of is true. The way most people use open source and consume it is through packages, which are kind of wrapped up and sealed. You're not grabbing the code and building it yourself in most of these situations, which makes it opaque. And that is a huge opportunity for people to insert malware or trick you into using the wrong thing, right? Even if you reviewed the code on GitHub, the package you installed might not necessarily be that same code. I think this XKCD comic here on the right really sums things up, a lot of this up today. We built these huge hyperscaling infrastructure setups on top of not necessarily well-supported infrastructure down here at the bottom. The reason I'm talking about this as part of Google's internal security is that we use open source everywhere, right? We're a huge company, but we built a lot of products and on top of open source software that isn't maintained. And it's a challenge to try to go through and dig through these towers that we built to find these and reinforce them. And I think most companies are in a similar situation today. All right, so let's go through some real world examples. I think it's a little more than 3 months now, but every time I update this slide, there's some new ones. These are some recent attacks though that have happened. This is one of the scariest ones at the top here, at the Great Suspender. This was a Chrome extension. One of the reasons this is one of the scary ones to me is because this was everything done perfectly correctly above board and it still hit a bunch of people. This was a Chrome extension to suspend tabs in your browser that were in the background. It saves battery life, makes your computer a little bit more responsive if you're one of those people that has millions of tabs open all the time. It was a popular project. It was on GitHub. It got a ton of stars, ton of usage, but the developer ran out of time to work on it. Right? This was free. The developer needed to move on, ran out of time to work on this kind of side project, needed a job, that kind of thing. So the developer sold the Chrome extension. Just like you can sell a business, you can sell popular open source projects. He sold that extension to somebody else who promptly stopped using the code on GitHub and started inserting malware into it. This was an example of people relying on something that wasn't supported enough for someone to make money off of, which led to an opportunity for an attacker to slip in. This type of thing happens all the time, and these dollar amounts are tiny, tiny, tiny compared to the budgets a lot of these attackers have. So this is something people have to be on the lookout for. Nobody was compromised here, right? The package manager wasn't compromised. The source control manager wasn't compromised. This was just the developer handing over the keys to someone else. So this is a tough one to prevent from a security and an OPSEC perspective. This other one, the next one, open source being able to be contributed to by anyone. This is an example that kind of blew up in the press over the last couple of months. It started in December, but bubbled back up maybe a month or two ago. This was a study done by the University of Minnesota where they were trying to inject malicious commits into the Linux kernel. They created anonymous email addresses, sometimes some of them were even their real names, and they sent patches that had bugs in them on purpose to try to study what would happen if those made it in. They ended up getting caught. Most of these patches didn't make it in. They were rejected at code review time. But this blew up and even led to the Linux kernel team kind of banning the University of Minnesota from contributing as a result of this. But I'm sure they're not the only ones trying to do this, and people are probably trying a little bit harder to sneak things in, and not every project has as thorough a code review process as the Linux kernel. So not everyone is nice, and it's really easy to hide malicious code in normal code and to make it look normal. Dependency confusion. So this one is an example, another one that was huge in the press earlier this year around making it too easy to use open source code. Turned out there were a bunch of large companies that were using internal package mirrors of open source code. So they'd review packages, pull them into their internal mirrors, approve them, and then you have all of their clients pull from there. Well, it turned out that a lot of these clients were designed so well to be so easy to use that if that internal package mirror wasn't available, or if a package wasn't found on it, they would just fall back and keep looking for it in other places. So an attacker was actually able to trick a bunch of these internal clients that thought they were accessing things inside the firewall of huge companies into grabbing code from this attacker's public repository, downloading it and running it inside of their environments. Luckily, this person was a researcher who reported it, hopefully got a whole bunch of huge bug bounties as a result. But again, these should all be kind of wake-up calls. This final one here, crypto jacking is the term for it. And this was an attack that happened on Ruby gems. There have been a bunch more recently across Node and PyPy and other package managers earlier this year as well, where people slip crypto mining code into open source packages that you download. So if you review the source code, you won't find it in there, but as soon as you grab the packaged archive from one of these package managers and install it, there's now a little crypto miner running on your machine, earning money for these attackers. We talked about ransomware a lot today, and ransomware is a huge problem. I've heard a lot of security researchers say things like crypto is one of the biggest benefits to security because it makes a whole bunch of these attackers go the easier route of just mining crypto rather than locking and encrypting data. So a lot of these crypto attacks are things that would have been ransomware in the past, but it's a little bit easier to exfiltrate and avoid detection this way. So these things happen all of the time. All right, the second part here I mentioned is that all of the software you're using, whether it's open source or not, all of the software you buy, the package software, the box software, even the services you use and you trust with your data is software. It's written by humans. It all has bugs in it, whether they're intended by one of these malicious people I just talked about or not. The software I write has bugs, the software you write has bugs, the software on GitHub has bugs. And a lot of those bugs can present security challenges and issues. And so we've got to find those bugs and stop pretending that anything we didn't write is perfect. Explain what I mean here. These are a bunch of the fancy bugs with the logos and the code names and everything that have hit the news lately. But these are examples of people finding bugs in popular open source packages and exploiting tons and tons of companies because of it. We've got Heartbleed, we've got Shell Shock, we've got the Apache Struts vulnerability that hit Equifax and a bunch of other huge companies because they were running out-of-date software. JWT libraries are another huge one where pretty much every JWT library out there has had bugs in it at some point. There's even a website that tracks how many days since a JWT library, an open source one, has had a critical vulnerability inside of it. These are bugs that weren't injected intentionally, but if you're not paying attention, if you're not scanning your code, if you're not scanning your supplier's code, they can affect you as a software vendor. Now let's shift over to some of the guidance, I guess, about what to do about these, and then in general, how to make yourself more resilient to these attacks. For these bugs, the bugs that are in your software, one of the big problems and misconceptions is that I just showed those flashing ones, right? These are the big 0 days that get the logos, they get the websites, they get a lot of press when they're found. They're usually found by researchers. Hopefully the researchers find them first. I mean, you never know with these if an attacker found them before the researchers. When the researchers find them, they go through a big embargo process. They get their big bounties after doing a nice coordinated disclosure and giving people time to update. These are the ones most people worry about and think about and spend most of their time trying to figure out what to do here. I think that's probably a mistake, actually. For the most part, you should have a plan in place to deal with these. Spend some time each year, each quarter, thinking about what would happen. If this critical software you've got running as root in all of your data centers has a 0-day found inside of it. Right? Think about what you would do for all of these. You can war game it. You can kind of role play, go through these situations, and have some kind of plan written down. Get the playbooks so you're not trying to figure out what to do in a huge stress situation when everybody's trying to roll out new versions. But beyond that, there's not too much else. Right? Don't lose sleep over these. There's nothing you can do about it. When they hit you, they hit the entire industry. Everybody's panicking at the same time you are. The second category, though, these are the known bugs that you forgot to update. Right? It's the same thing before, except you forgot to update, or you might not have noticed because they didn't get as much press, but they can still have just as much of an impact. And this is a boring mechanical fix. You've got to apply patches. You've got to update the dependencies in your code. It's time consuming. It's work nobody likes to do. Resolve conflicts, change function signatures all over. It's not exciting, but someone has to do it. It's much easier to do if you do it often, and you end up in a much better security footprint anyway. They get less attention, but you need to make sure you reward this work. Right? This is a culture problem. If you get hit by one of these, it's much more embarrassing. Right? Your customers are going to be much less sympathetic if you got hit and lost their data because you were running a 4-year-old version of something that's been patched for the last 4 years. It's much different than something that hits the entire industry at the same time and everybody is panicking and trying to deal with. Your customers aren't going to treat it the same way, and regulators probably aren't either. Right? Do not get caught by these ones. Make sure you have a process, make sure it's automated, make sure your team is constantly monitoring what you're running, you have a good inventory, and you're updating things as often as you can to deal with these vulnerabilities. These are the ones people should be spending more time worrying about. And this is tricky to do at scale as your software sprawls across multiple repos and your teams grow. Just knowing what you have running so that you can patch it is tricky. So what do we do when we do mess up? How do we make sure that we're resilient and we can come back from these things? Got a couple of principles here that we try to apply to all of our security at Google, but mostly supply chain is how I'm going to focus on these examples. All right, resilient supply chains. I talked about this a bit. What do I mean by that? And I've got this picture here. Right? These chains this is a chain made out of rubber bands. And that's what I mean by resilient, right? We can challenge the supply chains. We can find issues and we can recover from them. We can stretch it pretty far before something breaks. By break, I mean something that's irrecoverable, right? Losing all of our data. Losing all of the trust in our PKI and signing infrastructure. Right? These are ways to make sure that we can always recover from them and move forward even if bad things do happen. Overall scope of the problem, I talked about this a bit more, but I'll just reinforce it one more time to show how many different places some malware can slip in. Right? Huge numbers, right? These aren't small things, and I'm sure Michael's going to cover a lot of this more. But these are all the different places that vulnerabilities can slip into your code, intentional or not. It's going to happen, and it's getting worse. So the first principle here on what to do, and this is a great one for security in general, right? But you want to make sure you have a plan in place so that you can prevent a bad day from becoming a bad year or worse, right? When something happens, nobody likes this. You get paged, you get notified, an incident response team starts. You want to make sure that you have all of the tooling, all of the audit logging, all of the data, and all of the plans in place so that you can figure out exactly what happened. You can figure out what the blast radius was, and you can correctly recover from it. This is simple stuff that everybody knows they should be doing, but unless you actually go through and game out and play through some of these scenarios, you might not actually be doing correctly. Right? This means audit logs everywhere. For supply chain, it really means build logs, right? If you don't know all of the versions and all of the hashes and everything for all the different software components that go into your build or that you consume and you install on your servers from your vendors, then when you get notified about a vulnerability, you might not know if you're affected by it. Right? Make sure you have all of this somewhere that you can query as easily as possible. Right? This needs to be flexible. Right? You don't know exactly what you're going to be querying for until it happens. When the code cov breach happened earlier this year, that was a nightmare for a lot of people to try to recover from, because you had to query for a specific URL or IP address in your build systems between a certain date range. That's not a type of query you can plan out ahead of time and do with structured data. It's really just making sure that you have retention on these logs, they're stored somewhere else, and that you can look them up when you need them in these kind of creative and flexible queries. The next big one here, ephemeral environments, right? Especially for your builds. A lot of people, unfortunately, treat build servers as something lesser than their production environments, right? I've been guilty of this in the past, running Jenkins on a desktop that sits under my desk in the office somewhere rather than in a production environment. This is bad for so many reasons, right? We lock down our production environments, but we don't lock down these build servers as well. And this is how SolarWinds and a bunch of the other breaches have happened this year. People hack one of these machines, they can insert malware into the code that goes through it, and then that code gets taken straight into a production environment. And if these machines are running long-lived, you might not be patching them quickly. And if somebody does get an attack on one, then they can easily persist it, because that same machine is going to sit around and do all of the builds. Do best practices here. Use ephemeral environments. Spin up a new VM, spin up a new container for each build, and destroy it at the end. It makes a breach much more harder to persist and affect you long term. Scoped credentials, another like eat your vegetables kind of recommendation in the security area. Just apply the principle of least privileges to everything, including your build environments. If somebody steals the keys on your build machine, hopefully that doesn't give them access to publish directly to prod or to publish to all of your artifact repositories. When a compromise does happen, you know exactly what the credentials on the machine had access to, and then you can audit, delete, rebuild all of those things without having to spin up all of your infrastructure again from scratch. Putting all these things together and normal traceability throughout your pipeline can help you recover from a bad day much quicker. This is another one I like. This is a great quote. Secrets can't last forever, right? A secret is defined as something to only one person at a time. I think this kind of reflects it. Us as humans, us as developers in the security world, know that eventually you're going to lose your secret. Eventually it's going to leak, no matter what that secret is. So that's why we do rotation on keys. That's why we have plans in place to revoke certificates, that kind of thing. You will lose your secrets and treat them like databases, like that ransomware stuff we were just talking about earlier. In a database, backups only count if you can restore, right? Having stuff offsite in a place you can't get access to it doesn't help. So people knock out and practice restoring. Secrets only count if you can rotate them or deal with losing access to those secrets. There are a bunch of good technologies around here, especially in the supply chain space. If you're signing artifacts, this is one of the big ones. And then you lose access to your signing key, or you leak your signing key, or something happens to it, that's end of the world for a lot of people. You never think through what to do if you do happen to leak that PGP key that you've got on a flash drive somewhere in a safe. Leaking is one thing, and people can kind of rationalize that that's never going to happen. I think the bigger threat model for a lot of these signing keys, especially if you're using hardware tokens and stuff like that, is losing them. Right? It's a cup of coffee sitting next to your laptop that can spill and destroy that hardware token. Leaking the key is just as bad as losing it. Right? You need to get a new one. You need to establish trust again, so people know how to verify signatures from you. There are a bunch of different technologies and papers and stuff about how to recover from this. But if you are interested, take a look at the Update framework. The whole framework is designed to build secure update systems that can recover from compromises and key loss and key theft. Finally, this is an underlying theme we've talked about in a lot of these slides, but hope is not a strategy. Figure out what you're going to do when things do go wrong ahead of time, so that you're not trying to come up with it on the fly in a panic situation. Right? Just like a data center outage, just like your SRE teams normally do, you should be doing this for your security organization as well. What's the worst case scenario that could happen to your supply chain? What's the worst case scenario that could happen to your production environment from a security perspective? Think through these. You can have fun with it. You can do it once a year or once a quarter, something like that. Write some playbooks for it or game it out. You don't need to have answers to everything. Just having spent the time with your team to spend a couple hours thinking through what could happen. That's going to make it much, much more effective for you to recover from these things when they do happen. Brainstorm, come up with different scenarios, and maybe you can find some issues and figure out how to fix them and mitigate them ahead of time before an actual attack happens. Right, so in summary, supply chain attacks are coming. They're here. If you've been following the news at all, you're aware of that, hopefully. Open source is particularly at risk. It's particularly scary for us at Google. Advice, don't give up on hardening your systems, but at the same time, you should expect and plan for compromises and figure out how you're going to recover from them when they do happen. All right, that's all I have.
Excellent. Wow. One of the things that we're seeing, and I think it's really across the board, and you see IBM buying Red Hat, you see Microsoft buying GitHub. They're all, to a large extent following Google's lead in the importance of the open source community. Someone told me that I think Microsoft is one of the top 1 or 2 or 3 contributors to the Linux kernel. And if you had told me that a few years ago, I said, you must be confusing Microsoft, Google, or someone else. And it's a much changing world. And this, you see again, Microsoft shutting down its old Kubernetes container strategies and saying, Google did it better. Let's just, we're going to go to Kubernetes, which has evolved. So, I think it's very useful to get this insider's view and all the best practices.